calculus method, only then you must derive or you must show these steps. This is actually easy. If you know the integration, this is easy. Actually, you might not be studied integration okay, in high school classes. You are going to study this year and next year in mathematics in great detail about integration. But here the basic idea, basic just starting formulae are enough to derive these equations, okay, using calculus method. Okay, if you are really crazy about the subject, you can go through easy, no much difficulty, you can easily follow. Let me, to make my discussion complete, let me derive the three equations, v equal to v naught plus at, x equal to v naught t plus half at square, and v square equal to v naught square plus 2ax using the calculus method. First equation, let me derive first equation. Yes, we all know definition of instantaneous acceleration. A equal to, we all know, dv by dt. Instantaneous acceleration equal to A, equal to dv by dt. So this is A, means A by 1. So if you can cross multiply like this, okay. So dv into 1 equal to A into dt, okay. dv equal to A into dt. So what you have to do is, you have to integrate this both sides, or integrating both sides, integrating both sides. So we will write like this: integration of dv equal to integration of A dt. These are definite integrals. I have to give the limits, okay. So here first let me clear the point. V, for t and for x, three variables, and we all know acceleration is assumed to be constant, because we are going to derive kinematic equations for uniformly accelerated motion, right? Acceleration is assumed to be constant. It can vary, but for our simplicity we have restricted ourselves to constant acceleration cases. Okay, so here time, you all know, it varies from 0 to t, limits. From 0 to t, we have taken the time interval. When time was 0, x was x naught. When time becomes t, it becomes x. So therefore, x, the variable x, varies from x naught to x. Similarly, velocity, initially it was v naught, and finally it becomes v. These are the limits for v, t and x. Okay. Yes, now we shall continue. Therefore, integration of dv, yes, you are integrating with respect to v, therefore you must give the limits of v. Here dv, you are integrating with respect to v, therefore give the limits of v. Lower limit v naught, upper limit v. Here you are integrating with respect to time, give the limits of time, 0 to t, correct? So integration of dv between the limits v naught to v equal to integration of a dt between the limits 0 to t. Okay, next step, how do you do? I'll write here, okay. So integration of dv. So this one formula, simple formula, integration of dx between the limits, say a to b equal to, if you integrate dx, you will get x. This is the basic formula or basic thing in integration. You are going to learn about this in detail. As I mentioned in appendix, in the integral calculus, you are going to see in our textbook, okay, in third chapter appendix, you can go through, you can refer elements of calculus, integral calculus, differential calculus they have given, you just go through, okay. Integration of dx between the limits a to b, integration of dx is x, integration over from the limits a to b. That is, you give upper limit first, x equal to b minus lower limit a. That is how we are going to do, okay. So integration of dx is x, first upper limit you give, x equal to b minus, this is formula, minus upper limit minus, you substitute lower limit, x equal to a. Okay, so this is how it ends. So here same idea, you carry forward. Integration of dv will be v, integration over, don't put again integration symbol, this is a straight line, not integration. Integration is like this, elongated s, integration means summing, okay, continuous addition, okay, v naught to v equal to, here a is constant, as I mentioned, a is constant of integration. So because it's assumed to be constant, nothing to do with constant, it comes outside, it's not a function of time, okay, it is constant, it comes outside, simply comes outside a. If it is a variable, you must integrate, it is not a variable now, it is a constant, so it comes outside a into integration of dt, same, integration of dt is t between the limits 0 to t. Okay, so you may find it very difficult, okay, in the initial case. Actually, this is not that much difficult. If you know some basic about the integration, this is the first class, okay, of mathematics integration, nothing, okay. So you just substitute like this, upper limit x equal to b minus x equal to a. Similarly, v equal to v, upper limit minus v equal to v naught equal to a into, similarly, t, upper limit you give t minus t equal to 0, correct? After integration of dv, it becomes v, a is constant taken outside, integration of dt is t between the limit 0 to t. This is not integration symbol, integration over, okay, we have integrated already, upper limit v equal to v minus, this is formula, minus upper limit minus lower limit v equal to v naught, a constant outside, t equal to t minus t equal to 0. Yes, v minus v naught equal to a into t. Yes, you take here, you will end up with first equation of, so v equal to v naught plus at. This is the first equation, v equal to v naught plus at. This is actually calculus method. This method is very useful, okay, very useful. It has more advantages, okay, than or over graphical method. Okay, this is all about first equation. So you start with the definition of instantaneous acceleration. Yes, let me start. This is important for the next two equations. Same, okay, v varies from v naught to v, t varies from 0 to t, x varies from x naught to x. Yes. Now let me start the second equation. So starting step is the definition of instantaneous velocity. You all know, for the first equation we have used definition of instantaneous acceleration, a equal to dv by dt. Here definition of instantaneous velocity, v equal to dx by dt. Same, cross multiply. Therefore v into dt equal to dx, correct? Or I can write like this, dx equal to v into dt. Just rearrange, dx equal to v into dt, because in the second equation I want x, you have dx. When you have dx, you want x, no doubt you have to integrate. So integrating both sides, this equation, integrating both sides, integration of dx equal to integration of v dt. So you are integrating with respect to x, no doubt you are all comfortable with this. When you are integrating with x, you must give the limits for x. These are not indefinite integrals. Okay, if you write like this is indefinite integral. This is definite integral because it has fixed variation, fixed range. Okay, x naught to x equal to integration of v dt. You are integrating with respect to t. Therefore, give the limits of t, 0 to t. Right? Integration of x, that is integration with respect to x. Therefore, x limit, x naught to x. Here integration with respect to t, t limits. Fine. Next step, I will write here. Integration of dx between the limits x naught to x, correct? Integration of dx between the limits, same step. Wrote. Integration of, what is v from the first equation? From the first equation, we have v equal to v naught plus at, correct? Substitute the value of v here. Substitute the value of v equal to v naught plus at into dt between the limits 0 to t, correct? Between the limits 0 to t. Okay, yes, let us start the integration. Okay, integration of dx, it is x between the limits x naught to x equal to, now you have to split. I'll write one more step here. Integration of 0 to t, I'll split v naught into dt plus, correct, v naught into dt plus integration of v naught into dt over integration of a t dt, correct, integration of a t dt between the limits 0 to t, correct, v naught into dt plus integration of a t dt between the limits. Fine. Now integration of v naught dt. V naught is constant, no doubt it comes outside. You all know initial velocity is constant, therefore v naught comes outside. Integration of dt, same, integration of dt is t between the limit 0 to t plus, here acceleration is constant, that comes outside. Don't bring t outside because t is a variable. Integration of t dt. For this you must use another formula. Integration of x power n dx between the limits a to b. If it is like this, integration of x power n is an integer, x power n dx, integration formula x power n plus 1 divided by the same n plus 1 between the limits a to b. You are going to study about this formula, okay, in mathematics integration later. X power n plus 1 divided by n plus 1, okay, between the limits a to b. First x equal to b, therefore b power n plus 1 minus a power n plus 1, because x equal to b power n plus 1 minus x equal to a power n plus 1 divided by n plus 1. This is how it ends. Okay, let me repeat. X power n dx, integration of x power n dx is x power n plus 1 divided by n plus 1 between the limits a to b. So you substitute the value of b, 1 over n plus 1 is there, it do not contain x, only give values for x equal to b, that is b power n plus 1 minus x equal to a power n plus 1, this is minus formula. Okay, so same here, integration of t dt, that is t power 1, t is nothing but t power 1 dt, correct, a is constant, that has taken outside, integration of t power 1 dt, that is in the form x power n dx, correct, t power 1, integration of t power 1 dt between the limit 0 to t will be, I'll write here, where to write, okay, I'll write here, integration of t power 1 dt between the limit 0 to t will be t power 1 plus 1 n plus 1, n is 1 here, 1 plus 1 divided by 1 plus 1 between the limits 0 to t. Yes, t power 1 plus 1, that is t square, correct, t square 1 plus 1 divided by 1 plus 1 is 2 between the limits 0 to t. I think I made the point very clear. A is constant, that is taken outside. T power 1 dt is t power 1 plus 1, that is t power 2 divided by the same 2 between the limit 0 to t. Yes. Now substitute upper limit x minus lower limit, that is x equal to x minus x equal to x naught, x minus x naught equal to v naught into t equal to upper limit minus t equal to 0 plus half or a by 2 into t square minus 0 square, correct. Okay. Okay, v naught t, okay, v naught t, correct, x minus x naught equal to v naught into t minus 0 is t naught t and half into a into t square 0. Okay, I'll write the next step here. Okay, that is x minus x naught equal to v naught into t plus half a into t square, half a into t square. Now I will bring the x naught this side, you will end up with this equation, correct, x equal to, I will write here, x equal to, I'll bring this here, x equal to x naught plus v naught t plus half at square. Okay, this is second equation. X equal to x naught plus v naught t plus half at square. So this is how we can derive second equation using calculus method. As I mentioned, examination of point of view, okay, as per my knowledge is concerned, so this question won't be asked in the board examination, okay, but we must know actually this is an important method which is more advantageous over graphical method you are going to see in higher classes. Okay, calculus method more advantageous even for non-uniform acceleration cases, because the acceleration is uniform, a is assumed to be constant. If the acceleration is not uniform, we can derive the kinematic equation very easily, okay, using calculus method, but it is not that much easy using graphical method. Fine. So I think the last one, third equation of motion shall derive. Okay. Don't get afraid of, just go through the discussions, okay. So go through the discussions again and again, okay. So once the integration concept will be introduced properly to you people, okay. So this is nothing, this is very, very easy, okay. So before knowing the basic of integration, this will look very difficult. Don't get afraid of, be relaxed, okay. Just go through the videos again and again, try to use your common sense and some logic, easy, very easy. Okay. Okay, now let me derive the third equation. For this, the starting step is same as that of the first equation, that is A equal to definition of instantaneous acceleration, A equal to dv by dt, correct? So I can write like this, dv by dt as, only first step is same, okay, next step changes, dv, because velocity is a function of both position and time, okay, dv by dx, chain rule, into dx by dt. I can write dv by dt as dv by dx into dx by dt, because v is a function of both x and t. dv by dx into dx by dt. Actually dx, okay, cancel, same step. dv by dt could be written as, or can be written as, dv by dx into dx by dt. Okay, this is the small change in the second step, okay, for or to derive third equation. Same step for the first equation and the third equation, definition of instantaneous acceleration, A equal to dv by dt. So there you are cross multiplying and you will start integrating, but for third equation, to derive third equation, you need to rearrange dv by dt like this, dv by dx into dx by dt. What is dx by dt? dx by dt is instantaneous velocity, you all know. Next step, I am going to write dx by dt as A equal to dv by dx, rate of change of velocity with the distance, we don't know, okay, nothing, dv by dx only. What is dx by dt? Rate of change of position with respect to time, that is velocity, okay, v, dv by dx into v, correct? Okay, now just cross multiply, A into dx equal to v into dv, correct? A into dx equal to v into dv. Yes, just integrate, again integrating both sides. I'll write here, integration of a dx equal to integration of v dv, correct? You are integrating with respect to x, give the limits of x, that is clear. You must see dx, x limit, dt, t limits, dv, v limit, okay, dx, x naught to x. Here dv, you must substitute the limit of v naught to v. Again a is constant, okay, comes outside, that comes outside, it is constant, okay, for our case, a into integration of dx. Integration of dx is x between the limits x naught to x, a comes outside, integration of dx is x between the limits x naught to x equal to, here this is in the form integration of x power n dx between the limits a to b, that is, you all know x power n plus 1 divided by n plus 1 between the limits a to b, correct? So here v power 1 dv, that is v power 1 plus 1 divided by 1 plus 1 between the limits v naught to v, correct? So therefore a, okay, a upper limit x minus x equal to x naught over, so this is half, 1 plus 1 is half, this is v power 1 plus 1, that is v square, upper limit v square minus v equal to v naught, that is v naught square, correct? Half taken outside, v equal to v square minus v equal to v naught square. Okay, you just cross multiply 2a x minus x naught equal to v square minus v naught square. You bring this side, you will end up with the third equation of motion, that is v square equal to v naught square plus 2a into x minus x naught. General equation, you will end up with general equation, third equation, v square equal to v naught square plus 2a into x minus x naught. Okay, this is a simple method. First step same, second step just rearrangement, chain rule, then you are going to use the simple idea of integration. This is how we can obtain all the equations of motion. Okay, first equation v equal to v naught plus at, second equation x equal to x naught plus v naught t plus half at square, and third equation v square equal to v naught square plus 2a into x minus x naught by calculus method. As I said, this method has more advantage over graphical method. This method can be used even for the cases of non-uniform acceleration. Okay, so at that time you cannot take it outside because that will be a function of time or function of position. Therefore, you must integrate a, okay, with respect to position or time. So again, that is higher order. I think that goes beyond the scope of your textbook. Now let me discuss the free fall or motion under gravity as a special case. Okay, we have derived kinematic equations for uniformly accelerated motion. Now I am going to spend few minutes on free fall. Let us discuss free fall, the motion of an object under gravity, neglecting the air resistance. Okay, any object released from certain height, no doubt it will be attracted towards the center of the earth downwards by the influence of gravitational force. By the gravitational force, or because of the gravitational force, body will be acquiring some acceleration. We call it as a equal to g, that is called as acceleration due to gravity. Acceleration due to gravity we denote by small letter g. Any body released from certain height will be attracted by the gravitational force downwards, and that acceleration acquired by the body because of the gravitational force of the earth, we call it as acceleration due to gravity, denoted by g. And when an object travels a considerably small distance, okay, to the earth's radius, the value of acceleration due to gravity can be assumed to be constant, okay, constant, equal to the value, magnitude is 9.8 meter per second square, a equal to g, which is equal to constant. Okay, if the body covers a reasonably small distance compared to the earth's radius, you all know, huge, assumed to be constant acceleration due to gravity can be assumed to be constant, equal to 9.8 meter per second square. And no doubt free fall, neglecting the air resistance, comes under the same category. This is also a case of uniformly accelerated motion. Body is moving with constant acceleration g, not equal to a. Okay, constant acceleration g, which is equal to 9.8 meter per second square. Now the kinematic equations, three equations can be modified for free fall. We all know that v equal to v naught plus at, first equation. Second equation, x equal to v naught t plus half a t square, and third equation, special case I am writing, v square equal to v naught square plus 2ax, special case. Okay, Yes, v equal to v naught plus at, x equal to v naught t plus half at square, t square equal to v naught square plus 2ax. We can modify these equations for free fall, motion of an object under gravity, neglecting the air resistance. Fine. Actually, body is moving downward. The motion will be along the y direction, more correctly along the negative y direction. Correct? Body will be falling like this. It will be along the y direction. This will be plus y. This will be minus y. Okay? Fine. So along the negative y direction, and acceleration will be always downwards, because body will be attracted by the gravitational force always towards it. When a body is released from certain height, it will be attracted towards the earth, means always downwards. Therefore, acceleration A equal to minus g, because negative direction, you all know, in one dimensional motion we are not going to write vectors with the vector notation. As I mentioned that point at the beginning itself, we are going to use plus and minus sign. Plus means forward or upward direction, minus means backward or downward direction. Here acceleration is always downward. A equal to minus g, that is minus 9.8 meter per second square. Again, acceleration as magnitude 9.8 meter per second square. Direction is always negative. Okay, negative, always negative. And using or keeping that in your mind, substitute A equal to minus g. Okay, in these three equations, you will get the equations for free fall one by one. Okay, v equal to v naught plus at. I'll write here v equal to v naught minus gt, first equation. X equal to, here we are not going to write x because it is along the y direction, displacement will be y. Y equal to v naught t plus half into minus g into t square, that is plus half into minus g, that will be minus half into g into t square. Correct? Plus half into a equal to minus g, that will be minus half into g into t square. This is second equation. Similarly, third equation, v square equal to v naught square minus 2 into g into naught x, that is y. Why? Because the displacement is along the y direction. Okay. Yes, minus plus 2 into a equal to minus g, that becomes minus 2g into x. In place of x, it will be y. So this is how we are going to modify the kinematic equations for uniformly accelerated motion, particularly for free fall. As I mentioned, free fall is again a special case or another case. This is also comes under the same category. It's a free fall neglecting the air resistance, that is a motion with constant acceleration. So you just replace a by minus g in these equations. V equal to v naught minus gt, y equal to x, because it is traveling along the y direction, vertical direction, x equal to y, v naught t minus half gt square, v square equal to v naught square minus 2g into y. Fine. Now I can write the variation of distance or position with time, and velocity with time, and acceleration with time. I can plot for the free fall xt graph, that is yt graph. We are not going to write x because displacement is expressed as y. Yt graph, vt graph, and at graph for free fall. Before, if you assume the initial velocity, because when a body is dropped, from certain height, we all know its initial velocity is 0. It will be moving with constant acceleration, neglecting the air resistance, a equal to minus g, okay, and it will reach the surface of the earth. Okay. Yes, for this case, these equations will be v equal to v naught is 0 minus 9.8 into t. Okay, this is one equation which tells you the variation of velocity with time. Second equation, y equal to v naught into t, this is 0 because v naught is 0, minus half into 9.8 g into t square, that is equal to 9.8 divided by 2, that is minus 4.9 t square. That is equation y equal to minus 4.9 t square. So this is a equation, okay, which tells you the variation of displacement with the time. This is variation of velocity with the time. Okay, and third equation, you all know v square equal to v naught square, when v naught is 0, 0 minus 2 into 9.8 into y, that is minus 9.8 into 2, that is minus 19.6 into y, that is v square equal to minus 19.6 into y. Okay, so this is equation which represents the variation of velocity with the displacement or velocity with position. Here variation of displacement with time, that is position time graph. This is variation of velocity with time, that is VT graph. So this is how we can write the variations. These three equations shows you variation of velocity with time, variation of displacement with time, variation of velocity with the displacement as well. We can plot AT graph, that is acceleration time graph, VT graph, velocity time graph, and distance versus time, that is displacement versus time, that is YT graph, or position time graph, or the motion under gravity or free fall. First simple situation, let me write, this is y, this is minus y, okay. Okay, this is x. I am going to plot acceleration time graph. Okay, AT graph. Yes, you all know acceleration is negative. I am going to plot acceleration in meter per second square along the y-axis, that is y-axis, and the corresponding time in second along the x-axis. This is 1, 2, 3, 4, 5 time. So this is minus 5, this is minus 10, this is minus 15 meter per second square. Okay, here first quadrant is not required because acceleration is negative. Okay, you need fourth quadrant. T positive, T is always positive time, okay, and acceleration is minus. Fine. You all know free fall. Body is moving with constant acceleration A equal to minus g equal to minus 9.8 meter per second square throughout the motion. When you neglect the air resistance, okay, when the distance through which the object falls under gravity is small compared to the earth radius, we all know acceleration can be assumed to be constant, which is equal to 9.8 meter per second square in the negative direction. Fine, fine. At all time, 1, 2, 3, 4, 5, irrespective of the instant, acceleration will be 9.8, that is nearly 10. This is the graph. Acceleration is remaining constant. Okay, it's a straight line parallel to the time axis, you all know, but in the fourth quadrant, first, second, third, fourth quadrant, because acceleration is negative. So this is AT graph, which represents free fall, motion under gravity. Fine. Now let me write VT graph and XT graph. Again, first quadrant is not needed. Yes, we all know. Okay, because it is in the negative y direction. So this is time in second. Okay, 1, 2, 3, 4, 5 seconds. Okay, and this is velocity in meter per second. Okay, meter per second. Okay, I'll write like this, 9.8 or not necessarily. Okay, minus 10 minus 20 is equal calibrations, minus 30, minus 40, minus 50, and so on. Okay, now you can see this velocity versus time. Yes, velocity versus time. This equation will makes the point clear. Initially velocity was 0 at t equal to 0, velocity was 0, and when t equal to 1, v becomes minus 9.8. Give substitute values for t equal to 1, v becomes minus 9.8, t equal to 1, v becomes nearly 10 here. Okay, this is initial point, this is second point, and t equal to 2, it becomes minus 19.6, nearly 20. Correct, for 2 it is nearly 20. okay, nearly 20, like this, okay, and the graph would be like this. It's a straight line, it's a straight line, okay, point will be like this, okay, yes, it's a straight line, yeah, with the negative slope, with the negative slope. Why? Because the slope of the VT graph represents acceleration. Yes, acceleration is indeed negative. Yes, you must have a negative sloped straight line. Yes, this is VT graph, velocity versus time for free fall. Now let me write the graph, that is this equation is needed for me. Why? Because that will shows, that will gives you the variation of displacement with time, okay. Yes, this is AT graph, this is VT graph, VT graph, correct, velocity time graph, this is acceleration time graph. Now this is displacement time graph or position time graph, okay, YT graph. Yes, again same, body is moving in the negative y direction, correct, okay. This is time in second, okay, like this, minus 10, minus 20, minus 30, minus 40, okay, minus 50, minus 60, minus 70, like this. This is y in meter. YT graph, t in second, y, okay. Yes, this equation, y equal to minus 4.9 t square. You substitute the values for t equal to 0, the point will be this one. T equal to 1, t square is 1, minus 4.9 into 1, okay. For 1, it will be, this is 5, this will be 4.9, somewhere here, correct, somewhere here, fine. Then t equal to 2 square, 4.9 into 4, that will be 19.6, minus 19.6, for 2 seconds it will be nearly 20, like this, okay, like this, nearly somewhere here, okay, like this. So if you plot a graph, okay, like this, you will get a graph like this, okay. It's not a straight line, it is not a straight line, it is a curve, rough, simply giving the points, okay. So this is position time or displacement versus time, YT graph, for the motion under gravity or free fall, okay. So to understand the motion under free fall, we have plotted AT graph, VT graph and YT graph, acceleration time graph, velocity time graph and displacement versus time graph or position time graph, YT graph, okay. Change y, okay, instead of x it is vertical axis, moving moving along the vertical axis, okay. So this is how we can plot different types of graphs for any situation.